This is southern Alaska. Here, mountains stretch out as far as the eye can see, in a landscape of gigantic rivers and dazzling white glaciers. In this wild region of the USA, it's not uncommon to come across bears or moose. But with global warming, Alaska is undergoing a transformation. From landslides to collapsing houses, signs of permafrost degradation are everywhere. This is where a team of scientists has set out to study the effects of permafrost degradation. But what exactly is permafrost?
Permafrost is actually a thermal state. If there's water between the rocks, they aren't crumbly like this, but stuck together, cemented by ice forming a block. And when the permafrost with the ice degrades, the cement melts and becomes liquid.
Susan Conway, a planetary scientist at the French National Center for Scientific Research, CNRS, has come from France to study the Alaskan soil with her colleagues.
Yeah, if you've got little waves, you can do a little...
To get to the study area, the researchers must cross the Matanuska River. It's August, the only month of the year when the weather is mild enough for the field mission they're about to embark on. The current is strong. Only the most experienced are allowed to paddle. It will take several round trips to get the whole team to the other side. The journey continues on foot. There is no path. They have to climb the mountain through the forest while carrying heavy bags containing scientific instruments and camping equipment.
Yay! Oh, it's here!
But suddenly, they arrive.
Oh, yes!
Cone-shaped piles of rock from a gigantic landslide bearing the rather peculiar geological name of mallards have brought the scientists this far.
I've never seen so many mallards in real life. Little ones, big ones, they're absolutely everywhere. I've never seen so many in real life.
Scientists spotted this area using satellite images. The reason these mallards are so interesting to them is that they are a sign that the landslide was caused by permafrost degradation.
Before it became a cone, it was actually a kind of cubic block cemented with ice. In other words, permafrost, and was actually transported by the landslide. Since temperatures are higher at the bottom than at the top of the mountain, the blocks warmed up, causing them to degrade and form these cones called mallards.
The scientists want to accurately map the landslide. To do this, they first install a GPS station to serve as a reference point. Targets are set in numerous locations, and the GPS position of each target is recorded. All set. Now it's time to get a bird's eye view.
Today we're using drones to create a 3D model of the landslide in order to capture the individual shapes of the single mallards.
This requires a number of flights from specific points along the slope.
We programmed the drones to fly a certain flight path with a certain transect, and we're flying these at a 50-meter altitude, which will give us a spatial resolution of 2 centimeters. Afterwards, we're gonna fly it at 120 meters with a lower resolution, but this will allow us to nest the single flights we did before in the larger map.
For 2 days, the scientists will explore this massive landslide to determine its origin, record numerous GPS points, and fly over the zone time and time again. And to get as close as possible to the study area, they'll be camping right in the middle of the mallards. While this location is remote, landslides also threaten more populated regions. The other mission Susan Conway has set herself is to carry out research with the local population. We're in the village of Eklutna, about 10 kilometers from a lake surrounded by mountains. If a landslide were to occur, the lake could overtop.
And so these are our main infrastructure. If something were to happen to these, it affects anything going north in this state.
Carrie-Ann Brophil is a member of the municipality. She is concerned about the danger that threatens the village and its essential infrastructure.
If this were to slide off, it would take a good chunk of the mountain and let it slide into the lake, which would then create a tsunami. It would impact not only the village and the people who live down below, but it would also impact all of Alaska. It would cut off the state of Alaska on the highway, the main highway that leaves from the port to the rest of the state.
To assess the risks, the team returns to the field. They've spotted an area next to the lake that could be dangerous. They want to know what's happening underground. Determine the state of the permafrost. Is it degrading, and how fast?
Still a lot.
Wow.
To answer these questions, they installed temperature sensors at 5 different locations on the mountain.
12 centimeters.
There are air temperatures on top of each sensors, and we have ground surface temperatures. There are 4 of them in total for each setup. We are going to leave them for 1 year, and then we are going to retrieve them in order to have 1 year of statistics to build up our model to reconstruct the state of permafrost along the slope.
Once the model has been developed, they will be able to delve into the past using meteorological data, understand the state of the permafrost, and anticipate potential landslides.
If the permafrost really is degrading fast, then we need to start putting more sensors and other things in place. If the permafrost is actually stable, it's not quite as worrying. This is a first step towards determining whether we need to react quickly or whether a problem may occur in 20 or 100 years' time.
One thing's for sure, Alaska's ground is still shifting. In addition to melting permafrost, frequent earthquakes are contributing to landslides. Investigations are ongoing in other hard-to-reach areas. These studies will help to improve our understanding of this invaluable yet invisible permafrost.